Hi, this is our second presentation on IO streams. So in the last video, we have discussed about what is input stream and what is output stream. Input stream reads from various sources. Output stream writes onto various destinations. You may ask me what are the various source and destinations are. For the input stream, the sources to read are from file, byte array, char array, standard input, socket, etc. To the output stream, the destinations are standard output like monitor, file, byte array, some into char array, and into socket are the destinations. So, in order to perform reading from source and writing on to destination, two basic methods are given in input stream class and output stream class that we have seen in the last video. Input stream class is having read method, output stream class is having write method. And also in the last video, I have shown the complete class hierarchy of input stream class and output stream class. I think input stream class, all the input stream subclasses are shown. So in all the input stream subclasses, input stream class read method will force to override read method because the read method is abstract in input stream class. Input stream class is also abstract. So every subclass of input stream class must override that read method and implement that read method. That's okay. So that's how we discussed about input and output stream. And also we discussed about two types of other streams. They are and apart from input output stream, we too have discussed about reader and writer. So what is the difference between input stream, output stream and reader writer in brief case? Input stream and output stream read and writes only the characters within the ASCII range. That means from 0 to 255. Not beyond that. So input streams, because input streams gives 1 byte of memory for each character. In that 1 byte of memory, only ASCII range character value can be stored from 0 to 128 to minus 128 to minus 1. So only ASCII range character value can be stored into 1 byte memory. That 1 byte memory is allocated by input streams during read operation. Similarly, in readers, in reader for each character while it is reading, it will allocate 2 bytes of memory. So why 2 bytes of memory? Because reader classes are capable of reading Unicode character sets which are ranging from 0 to 65,535. That means 65,536 characters. So for each character, 2 bytes of memory is allocated. From 0 to 32,768 to minus 767, from minus 32,768 to minus 1. So a character from any of the Unicode range can be accommodated in 2 bytes of memory. So reader class always occupies 2 bytes of memory for reading each character. Input stream class occupies only 1 byte memory for reading each character. The same thing is for output stream and writer also. Output stream treats every character occupies only 1 byte memory. And writer always allocates 2 bytes memory for each character. So depends on the data, whether your data is within the ASCII range or Unicode range. As a developer, you have to determine whether you go for input output streams or reader writers. Otherwise, almost except the class names are different. Their methods are same, their constructors are same, their functionalities are same, everything is same. So that is how we finished one example in the last video. And also we saw how to read one text file from read data from the text file using file input stream. That example is completed. Now this is the continuation to the first example, second example. Before going to the second example, I would like to show you file input stream class, the class API documentation. You tell me what are the parameters that file input stream class constructor takes. File input stream class constructor can take file object as argument or file name as argument. It can take file object as argument or file name as argument. It can take any one of the argument. And the file input sim class constructor is clearly reporting file not found exception. I'm telling you, even as a developer, even when you write your own method, in the method, under any context, if you raise any exception using throw class, as a developer, you remember it is your responsibility to mention what are the exceptions your method is throwing. Those exceptions you must report in the throws class at the end of the method. As a developer, you make that practice. So even the file input sim class constructor also, it is reporting file not found exception. And the constructor says if the given file name is not found, I may throw file not found exception. Okay, two constructors. These two are constructors. And what is the very important? And here I'm writing only important methods, but not the other methods like available, skip bytes, close. I'm not writing all the unnecessary. I don't say unnecessary methods. They're not frequently used. Hardly close method is extra use. But the main important methods of file input sim class are read. If you use read, every time you can read one character from the file, from whichever file you're reading. And one byte you can read one character. Its ASCII value will be written. That is called as 1 byte. Reading 1 byte. Reading 1 byte means here we are not reading any bytes. Here we read character. But for that character, if that character is within the ASCII range, 1 byte memory is sufficient. So that's why people say that input stream always reads stream of bytes. It doesn't mean that it reads as bytes. Where bytes are used. The character ASCII range value itself is 1 byte memory. That is why they call it input streams read stream of bytes. A reader reads a stream of characters. Both input stream and both readers will read stream of characters only. But one will read within the ASCII range characters, one will read up to Unicode range character streams. Okay. So here read method reads one character, its ASCII value will be written as int. Suppose if you don't want to read one byte, if you want to read one buffer at a time, like 5 bytes, 10 bytes, 50 bytes, 20 bytes, like that, half KB, 512 bytes, 1024 bytes, 1 KB. Like that, if you want to read huge amount of data at a time, you create one empty byte array before. And before calling file input sim.read method, you create one empty byte array. And in the read method, you pass the byte array. Before creating byte array, the byte array is empty. The byte array is empty. Byte array. See, you may ask me one question that how would I know that how much memory, how much data is available in the file? Because here I am creating 1024 size of byte array. The 1024 size of byte array, we pass this argument into read method. And then now we are asking file input sim class to read 1024 bytes of data from the file. The file is not having 1024, what happens? Don't worry. You give 1024 bits, but as many number of bytes available in the file, those many number of bytes will be populated into this byte array. But it is an empty byte array. You created size of 1 KB, but as much amount of data comes from the file, that much content will be populated into this byte array. You need not have to worry about that. So that is the advantage of and once after the read method is completed, this byte array now contains all the characters came from the file. So like that, you can read a bunch of data also using read method. And there is one more option available. So here what you can do is, and here this one. See here available number of bytes, and because byte array size is 1024 bytes, if the available number of bytes are more than 1024 bytes, they will come into this byte array. You print it. Now where is the position? There is a methods. There are methods available in the file input sim class using which we can find out where the kernel position last hearted. From there again you can read 1024 bytes, and you continuously check whether or is the read operation. And while read operation is reading each and every character from the file, it will maintain a mark. Okay, I finished this character reading. I finished this character reading. I finished this character reading. Like that, it will keep a mark on each and every character. Next time, if you ask at what position the character is marked, it will show you up to what extent you have read. And you can calculate how many number of bytes are available. Again, all that you have to do it manually. Available method, mark, who is mark supported. There are so skip bytes. So many functions are available in the file input sim class. So using which you can read. Otherwise, you can do one thing. You create 1024 bytes of empty byte array that you give as argument in the read method. And in the file also you specify from 0th byte or from 100th byte, I want to read up to 1024 bytes. And 0 to 99 bytes are already read. From 100 byte to 1024 byte, I want to read. And 1001 to 1024 bytes. And if you read from 100 to 1000, this is length. This is length. Okay, no problem. 100 to 1024 is not a problem. From 100th position to 1024. Okay. So, like that, you can use various varieties of read methods on file input sim class. And similarly, coming to file output sim also, in the file output sim class, if you pass any file name as argument in any one of the constructor, this method writes, this class write method writes that data into the specified file. This class is having quite opposite to input sim class read method, or file output sim class is having write method. In this write method, if you pass any byte or byte array as argument, so whatever characters exist here, that amount will be returned to the file name you mentioned here. So there are 3 constructors available in the file output sim class. One constructor will take file object as argument. We'll discuss about file class later on, because input output sim concentration will be diverted if we discuss about file class, file name filter interface, and those other stuff. So I'll discuss file class later. File class is nothing but one class object which will take the file name. With the help of that file object, you can check whether is it a file or is it a directory, what is the size of it, whether is it readable or writable. Some sort of file related information you can retrieve with the help of file object. So if you are not convenient with this, you can use second constructor. File output sim class contains file name as a parameter. Okay, so in file output sim class, you pass file name as argument. And here is there is one more constructor. File output sim class constructor is taking file name as argument and boolean value append also. Be small because of word or PPT is converting it capital. So the second one is boolean argument append. So then what is the difference between these two? Here I have written that important point. Every time you create file output sim class object and point to some file and start write operation will write the data from the beginning of the file. Okay? It will always write the content from the beginning of the file, but it won't append the content at the end of the file. Every time you open file output sim class object and start writing, it will start from the beginning of the file. As much data as you write. Once you close, and once again if you open file output sim object on the same file and start writing, it will again start overwriting from the beginning of the file, but it won't append. Because file input sim and file output sim are sequential streams, I told in the very introductory session itself. If you want to append new content to the already existing content of the file, I said I asked you to use a random access file. A random access file you can use to perform such operations. But here also in file output sim class, one facility is given. You can pass file name as argument and boolean append. So next time if you open file output sim class object on the already file having content, in that if you give boolean argument true and start writing, at the end of the file the content will go and append. And this special instruction must be made, otherwise the past content will be overridden. So please be careful. And here also write method does the same job. In the file output sim class, write method, you can pass 2 things. You can pass capital letter A or you can pass 65. You can pass int or character because it is taking int as a parameter. In that method you can pass the character's ASCII value or the character itself. So wherever a method is taking int as a parameter, there you can pass character or value. So then if you pass character, what will be treated is its ASCII value will be stored there. So using write method, you can write one byte into file. So the write operation becomes slow. If you want to write one buffer at a time, then if you are already having a byte array filled with some data, you give that to file output sim write method. As much data exists in this byte array, it may be 1024 bytes 1 KB or 2048 2 KB or 3 KB 4 KB, as much amount of data as you are having in this byte array, once you pass it into write method, that whole data will be returned to the file. So file input sim and file output sim are the 2 very important stream classes in IO package. In the first example, what we did is we just read only file data and displayed on the console. In this example, we are reading data from the student details.txt and we are writing into another file called student details1.txt. And this is student details 1.txt, this is student details 2.txt. Here program file input stream reads the data from the student details.txt, and using file output stream, the same data will be written to student details 2.txt. That's all. Simple operation. Actually, I must mention one diagram like this for better understanding in a program. So here I am opening two stream objects, a file input stream object and file output stream object. In the file input stream object, I am passing file name as argument. This file must be presented in your local directory because file input stream reads data from this file. If the given file is not available, this exception is thrown. File not found exception is thrown. Remember. And then the file name which we are passing as argument into file input stream class constructor, that file must be present in your system hard disk. And coming to the file output stream, in the file output stream class constructor, whatever file name you are passing as argument, this file shouldn't be there. This file is automatically generated by file output stream class, and this file should be a non-existing file. Into that file output stream will write the data. If already a file exists with this name, what happens? Then that old content will be overwritten. That is what happens. So, two file input stream and file output stream objects are created. So then what we have to do? We have to read one character from the first file and write into second file. What to do? File input stream dot read. So from the file, suppose for example, if the file content is one ABC and a student ID, student name, email abc@gmail.com, and the next mobile number 9848-12345, something like that. So first time when you call file input stream.read, this one will be read. Its ASCII value. Its ASCII value will be written to this side. And we are seeking what is the range of ASCII 0 to 255. So as long as the data exists in this file, the characters corresponding ASCII value, any value from 0 to 255 range will be written. Suppose if there is no data available in the file to read, if the file input stream reaches to the end, then what file input stream class read method will do is it won't throw any exception. It will simply return -1. And once a file input stream class read method returns -1, what does it mean? You reach to the end of the file. Even after reaching to the end of the file, also if you are trying to read any data from the file using read method, then you will get an IO exception or EOF exception, end of the file exception. Okay. Anyway. So read method, you called that character ASCII value will come to I. If I is not equal to -1, then what you do? Here I am just printing for debugging sake to just see how the file content, the file input stream class is reading. And using file output stream dot write. File output stream dot write method can take two things. It can take, as I told before, you can either give character or character ASCII value. Because here we got character ASCII value, that character ASCII value we are passing into write method. Write method takes int, but it won't print int. It won't write int. It writes its original character to the file. And the original ASCII character will be written to the file if you give ASCII value here. Then in order to see the output on the screen, every time, in the loop iteration, I am waiting for 100 milliseconds. 1000 milliseconds, 1 second, 100 milliseconds is equal to 1000 seconds. The next file input stream dot, again, one more time we are reading. Now this time, the second value, the ampersand ASCII value will come. It's not -1. Again, write it into file, sleep for some time, and again reads ABC, A, it will read, the next B, C, and so on. So that is how the loop will iterate until all the 4 or 5 lines of the student details.txt file is completed. Once it is done, close the file output stream and file input stream objects. File output stream and file input stream objects. This is reading local directory file and writing onto local directory file. Reading from local directory file, writing into local directory file. And this is a text file. Text file contains characters. Coming to file input stream, file output stream demo 2. The two also I made 2_1, 2_2. different examples I did. What this example does: reading local directory image. Oh, it's not a text file; it's image. Reading local directory image and writing into current directory file. And reading images. First example, reading text file. Second example, reading images. That to byte by byte. Okay. So class declaration, main method, file input stream is equal to new file input stream of. Here I am giving the path of a file. One local file exists in our system. Tulips.jpg. Tulips, some images are there in my pictures folder in every Windows operating system. So in C users, public pictures, sample pictures, tulips.jpg. In that folder, one image exists, tulips.jpg. We are pointing to that file. When you are giving the path in file input stream class constructor, you must give double backslash. Double backslash for the directory separation. So once that is completed, the next second one is file output stream FOS is equal to new file output stream of tulips.jpg. So we want to write it, we want to read from this file, we want to write into this file. How to do? File input stream.read, and from the file you read the first byte. If it is not -1, write into second file. And now the data coming from the tulips.jpg file, it is not a text file, it is a binary file. The characters are not printable and unreadable characters. You open any image file or notepad, you will come to know how the binary content of the image file is. Image, PDF, Word, Excel. You open those files on any notepad, you will get all the some binary data. So here, whatever character comes, it's ASCII value, and these characters are from 128 to 255, I guess. Because 0 to 127 are printable characters, the characters which are available on the keyboard. We can type them. Flower basis, angular bracket, square basis, parenthesis, minus, plus, addition, subtraction, multiplication, division, percentage, character, all the symbols are 0 to 127. So 128 to 255 are some special characters. So whenever you open image file in Notepad, you will find characters within this range. But these are also characters within ASCII, but not up to Unicode. So whatever the character ASCII value comes, that value will be written to second file. This program don't know whether is it an image file or text file. Read every character ASCII value, write into output stream. Second file. That's it. That is how the complete process will be completed. We are closing file output stream and file input stream objects. This is reading. Previous one is reading local directory file and writing into local directory file. This is reading local directory image called local system image. Reading one image from the same system, within the system, and writing into our local file. Reading image from our within the system and writing into our local file. And this is reading remote location image and writing into our local directory or current directory. So what does it mean? What is the meaning of reading remote location image? What is the meaning of remote location image? Remote location image there. See, which input stream can point to the URLs on World Wide Web? Which input stream class is capable of reading or pointing to a URL? So we are having file input stream, we are having byte input stream, we are having socket input stream, we are having object input stream, we are having string buffer input stream. In the filter streams also, data input stream, buffer input stream. There is no input stream class I found from this entire input stream class hierarchy that points to an URL of some World Wide Web location. Then how to open an input stream object on remote files, the files that exist on World Wide Web. And then the solution is, here we need to import one more package called java.net. Java.net package consists of all the network related classes such as URL connection, HTTP URL connection, init address, and that IP address to domain name to IP address, that resolution you can do through INV headers class. URL connection, HTTP connection, INV headers, socket, server socket, datagram packet. All these classes exist in Java.NET package. So in that package, there is one class exists with a name called URL. URL U is equal to or URL is equal to new URL. Here I am completely giving the path of the PNG. Actually, I recently tested whether this image is not tested recently. Yesterday only I tested whether this image is available or not. This is an already existing image on the World Wide Web. The existing image path I have given here. Hence we are calling it as URL. What is the difference between path and URL? Path points to your local directory. URL points to remote location. That is why URL always consists of protocol. Various parts of the URL. Protocol, colon, / host name, colon port number. Host name, colon port number together called as host / directory / file. These are various parts of the URL. Protocol, colon / host name, colon port number / directory / file. So with the help of URL class, we are pointing to some image exists on the World Wide Web location. URL is equal to new URL of some location. The next, we want to read from that URL and want to write it into local directory, local file. So file out to sim f is equal to new file out to sim of google.png, because we are reading Google image, we are writing into google.png. But how to read input sim from that URL? URL class is having one method called OpenStream. You please visit URL class in Java in API documentation. So in URL class you will find one method called OpenStream. So this URL object dot OpenStream method opens an input stream for the above URL. Then you need not have to worry about how to open input stream object for a URL. First you store URL or you pass URL into URL class constructor. You create one URL object. URL.OpenStream method will open an input stream. That's it. So from the input stream you read each byte. If it is not equal to -1, write it into local file and print one character here also. This is not required. You can comment it. Read next byte. Again check. If it is not -1, write. Again you read. Again you check. If it is not -1, you write. And keep on. You continue like this until the file reaches blank. Complete image will be copied. Some other directory image will be copied into our directory. So finally we are closing file out to sim.close and file input sim.close. While closing the streams, recently opened stream must be closed first. Early opened stream must be closed last. And actually, anyway, no problem. But we should close input stream first and the next output stream. No, output stream first and then input stream. Because output stream is depending on input stream. So close the child first and the next parent. That order is okay, no problem. And here is an example. Reading remote location image and writing into current directory file using buffer stream. Here also we are doing the same thing. Here we are pointing to some Google _1998.logo.png. For example, let us assume that if this image is 350 KB. 350 KB means 350 into 1024 bytes. You calculate how much will come. 350 into 1024. These many number of character by characters you need to read from the World Wide Web server and give each character to file output stream to write. And to your file output stream to write into your file, you are giving one byte and a one character or one byte, whatever it is. One byte you are reading from a World Wide Web resource. Then you go to internet from the server, you fetch only one single byte of that image file, write it into local directory, again you fetch single byte and again write it into local directory. So how much time it will take? 350 into 1024 bytes. Those many times you need to read from World Wide Web resource, World Wide Web server. See how pretty time consuming, boring. Because applications runs very fast. The moment you start the application will end up. If you want to see the difference, how each byte it is reading, you write the thread.sleep here, you will come to know how slow the process is. So, in order to overcome that, I did one more example. Reading remote location image and writing into our current directory file using buffered streams. So, what is buffered stream? Data input output stream and buffered output stream, buffered input stream are the filter streams. What is the advantage of buffered input stream or buffered output stream? So, buffer streams advantage is they can read one buffer of data, they can write one buffer of data. So, for example, if the file size is 350 KB, if it is 350 KB, 350 divided by 1024, 1 KB is equal to 1024. 350 divided by 1024, some 35.0 something you get. And 35 times, each time if you read 1024 bytes, then this 350 KB content will be read. Suppose if it is 350.2 something like that, then the file size is 350.2. Sometimes it may not be exactly 35 KB. Sometimes it may be 35.2 KB, 35.3 KB, 35.5 KB, something like that. And they're not exactly round figure 2024 bytes. If it's 35.2 KB, then we should not read for 35 times. We should read for 36 times. But because otherwise, the last couple of 0.2 KB of bytes, and 0.2 KB of bytes means some 200 bytes or something will be lost. So image will be corrupted. So how to write a logic for this? Actually, we don't know how much size that file size is. Right? But we want to here. What are we doing? This one. Say this. That's why this example of reading remote location image. Here what we are doing, same with the help of URL class, we are pointing to some file, google.png, from Wikimedia from some folder, google.png. In the previous example, we saw URL connection.openstream. URL.openstream. URL.openstream method returns an input stream object using which you can read byte by byte, and write byte by byte. That is the previous example. Now we want to read from the same URL, but not byte by byte, somehow by buffer by buffer like that. Then if you go to this URL class and try to find out in the entire URL class, you don't find any function which goes and calculate and returns the length of the file. And there is no function available in the URL class to find out the length of the file. That is why in URL class there is one function given called open connection, and internally it's a socket connection. URL.open connection that returns a URL connection object, and this URL connections will be taught more in the Java.NET package, network programming. So URL.open connection method will return a URL connection object. In URL connection class, get content length method is there. We call the get content length method. This URL connection. It is a direct socket connection to the server. It will go there, find out the content length of that entire file, and returns back to us. Content length comes in such a way. Suppose if it is 35 KB, not 35 KB will be written here. 35 into 1024 bytes, or 35.2 KB, or 35.3 KB, something like that. Let us assume 4 KB, something like that. Then that much, 3 to something. The number of, and the length will be written in terms of number of bytes. And the image will be shown as a KB image, but here when you call the length, a KB length will be written. So like this length comes. The next URL.openstream. And then to get the content length on URL, we opened URL connection object. Again, we said URL.openstream. Input stream came, but we don't want to read byte by byte. We don't want to directly use read method. Okay, remember. And again, into local file we want to write file out to sim FOS is equal to new file out to sim of Google1.jpg. Already Google.jpg is written in the last program. This is Google1.jpg. Okay. Google1.jpg. The next, what comes next? This input sim object we are passing into buffered input sim. The buffered input sim class special ability is it cannot point to any file or anything. But whichever object you give it to buffered input sim class constructor, it reads from there. And a buffered input sim class always reads data from the another input sim object you are giving as input. So here you are giving input sim object into buffered input sim class constructor input sim, and this input sim is pointing to URL input sim. URL input sim is pointing to this URL. That you said you are asking by buffered input sim to read 1024 bytes of data. And as a developer, you can specify how much size of data buffered input sim want to read from this given input sim. You can say 1 KB, 2 KB, 3 KB, 5 KB, 10 KB. As a developer, it is in our hands. We can decide according to our convenience. Similarly, we want to write it into another file. Buffered output sim device is equal to new buffered output sim of file output sim. File output sim means this Google1.jpg. Again, how much each time during write operation, how much data we want to write? 1024 bytes. And 1024 bytes we want to read, 1024 bytes we want to write. Good. And the next, now buffered input sim and buffered output sim are ready. This will read from the URL. This will read it into local file. That to buffer by buffer, not line by byte by byte. Okay. The next what we are doing is, here we got the length, right? Here we got the length, content length. So the content length divided by 1024 if you write, you will get exact size, 35 point some 35. It's not exactly 35, but I am assuming that if you write that length divided by 1024, you will get some 35.258, something like that. Okay. Or maybe 35. We don't know. If it is 35, 35.0. But length divided by 1024. And any integer you divide with another integer. If you divide any two integers also, the resultant output, not only Java programming language, remember in Python, PHP, Java, C, 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 C++, everywhere. If you divide two numbers, the resultant output is always a floating point value. In Java, it is double. So you will get a value like this. That you will get here. How? Why we are finding the length and why we are dividing by 1024 bits? Because one buffered input sim class read operation can read 1024 bytes of data. But how many 1024 bytes of data want to be returned from the file? That we don't know. That all depends on the size of the file. And for that we need to find out the length of the file. The length divided by 1024, we come to know how many number of iterations we can read the whole file. Because it's not read line by line or byte by byte. No, isn't it? It's a buffer by buffer. So that is why we are finding the length divided by 1024. You will get some value like this. Now, every time I am printing here that value because to debug the application. Okay. If I get 35.28258 or 35.0 or 35.678, suppose 35.258 if you pass it into math.floor function, you will get 35. If you pass it into math.ceil, you will get 36. If you pass it into round, if it is 35.5 and above, it will become 36. If it is below 35.5 below, it will become 35. The round will do like that. So the right method here in math class among the ceil, floor and round is ceil, upper value, not lower value, upper value. So why we want upper value? Because 35.672 or something like that you are having. That 35 want to become a 36. So we pass it into math.ceil, you will get 36.0. That 0 still continues. How to convert double to int? To convert double to int, we can do one thing. We can do typecasting. Double we can convert into typecasting to int. Second one is in the wrapper classes we learned. Suppose if you are having double value, that want to be converted into other primitive type. First you store double value into double class constructor. And you store double value into double object. In the double class, in every wrapper class. Byte value, short value, int value, long value, float value, double value. 6 methods are given. First you store primitive double value into double class constructor. You create double object. Double dot int value. It is 2 lines. Instead of writing 2 lines, if you directly type as double value into int, you put bracket and write int, and in int variable if you take, directly double value will convert into int. That int is nothing but the number of iterations. The number of iterations. Now here you will get iteration. And every time I am printing the value, I am seeing how much actually the value is. So iterations we finally found. Okay, then what we want to do is for loop int I is equal to 0, I is less than iteration I plus plus. And those many times you are iterating. And every time I am creating a new empty byte array. New empty byte array. Here I am creating an empty byte array. Now it is completely empty. So in the buffer input sim dot read method, I am giving this byte array. So what buffer input sim class read method with empty byte array will do from this byte array input sim, and from this buffer input sim, not byte array input sim, from the buffer input sim points to file input sim points to URL input sim points to URL. And this buffer input sim dot read method will read at a time 1024. That too in the constructor we explicitly mentioned to the buffer input sim, you read 1024 bits each time. That much it will read and populate into this empty byte array. So this read method will read 1024 bytes into this empty array. That array you give to write method. Buffer out sim is pointing to file out sim. File out sim is pointing to google1.jpg. So it will into google1.jpg file. That entire 1024 bytes will be written. Again, second 1024 bytes. Again write. Again third 1024 bytes like that. So every time like that 1024 bytes of data will be read and written to the logger file with this logic. This is reading remote location image and writing into current directory file using buffered input sim. Previous example is byte by byte. Byte by byte I think problem is you can directly check with -1. Because here we are using buffered input sim, we don't know how many number of times we want to read 1024 bytes. For that we made this entire calculation, getting the content length divided by 1024. Again seal the value. The next convert the value from double to int. Finally, that is how we are determining the number of iterations. This is simple. This is a simple example. And here almost reading and writing from files are completed using various streams. Here the example is reading from one byte array and writing into another byte array. It's a simple example. And file input sim, file out sim is completed, and buffer input sim, buffer out sim is completed. Now we are covering byte array input sim and byte array out sim. So byte array input sim will read the data from byte array. So how to create class declaration main method? How to create byte array? Byte array can be created any array can be created in 2 ways: static way, dynamic way. Static way means you create array, mention the size at the time of declaration itself. Later on, into each index of 0, 1, 2, 3, you assign unknown value. That is static array declaration. Otherwise, you make dynamic array declaration. How? Just open flower vases. In the single quotation, you write A, C, T, I, like that. And you assign one character into this byte array, or find out the ASCII value of each character. And with only ASCII values, you create one byte array, no problem. And through ASCII chart, I found all these ASCII values. Through ASCII chart. So you create one byte array with characters or with bytes. Next, where we have to give this byte array. Which class in input stream class hierarchy can capable of read from byte array? Byte array input stream. Byte array input stream BIS is equal to new byte array input stream of byte array we are giving from 0th index to how much? To till the end of the length of the byte array, b dot length. The byte array will understand. Each time if someone calls read method on me, from this byte array, from the 0th index, I'll read up to this much length. That length is nothing but the byte array length itself. So, buffer output stream. Buffer output stream says you specify the length. And whatever you are reading here, that empty byte array filled with these bytes, the data coming from this byte array, that will give to byte array output stream. So byte array output stream internally maintains that buffer, and finally we can extract the data from it. So byte array output stream. So here what I am doing, byte array output stream dot read one int value, and instead of reading buffer by buffer, here I am reading byte by byte. So first byte we read not equal to -1 with the help of byte array output stream. We are writing into local byte array. Again read, again write, and so on. Finally, the data coming this byte array now comes to byte array input stream. This is reading, and it will write byte by byte into this buffer output stream. And the whole process of writing will take place into byte array output stream. And inside byte array output stream, one temporary array will be created. Into that, all the 1024 bytes of data or something, this much of data will be dumped into byte array output stream. Now finally, where the data is available, the whole data is now consumed by, it is in the stomach of the byte array output stream. So now you ask byte array output stream to give that byte array into the program. So you call byte array output stream that to byte array method will convert the content coming from byte array output stream into byte array. So this is how you got byte array, and here we are finding the length of the byte array using for loop. We are retrieving and displaying each byte on standard out. So same content will be displayed, but this is one traditional way. Finding the length starting from 0th index to till less than length is the old way of iterating OR array. The latest way is enhanced for loop. For the byte array is B1. For byte B2 column B1. From the byte array 1, from this array, each byte will be populated into this byte B2. So that B2 and the corresponding character we are printing here. That B2 and corresponding character we are printing here. That's all. Byte array output stream closed, byte array input stream closed. And here the extension of the program is written in such a way to print ASCII values from 0 to 127 and 128 to 255. And if the developer wants to print the ASCII value from 0 to 127 and 128 to 255, then they can avail this code. Otherwise, you can keep this entire code comment. And this is the program on string buffer input stream. String buffer input stream class is capable of reading data from string, not from string buffer. The name named as string buffer input stream, but it will read data from the string only, but not from the string buffer. So here I wrote a class main method. One string I declared, string str is equal to I'm fine, how are you, who are you, how do you do, something like that. Okay. The next using string buffer input stream class. Into string buffer input stream class constructor, we are passing string object as argument. String buffer input stream class is capable of reading data from string. So what is the input required into it? String. So before string buffer input stream, you declare one string, you assign some value to it, pass it string as argument into string buffer input stream class constructor. From the string buffer, you retrieve each and every byte. And either if you are interested, you print it on the console, or you can write it into a file also. So read each byte. If it is not -1, print that character's original character. And each I, we are typecasting into character to get the original character. Again read the next byte. Again not -1, print the character. Like that till end of the string. And once one input output stream class program is understood, we can understand the remaining programs also. Here is a previously I have shown input stream class hierarchy. This is the output stream class hierarchy. In the output stream class hierarchy, what are the direct subclasses of output stream class? File output stream, socket output stream, byte array output stream, object output stream. Piped output stream example is also ready. That may be covered in the next video. And again, filtered output stream. Filter output stream is also a subclass of output stream. From the filter output stream, data output stream, buffer output stream, print stream. All these streams examples we'll see in our applications. And checker output stream, this will come in the zip operations, I think, zip and jar operations. Ciphering comes in the security. Inflator, deflator also comes in compression decryption only. Digest input stream again comes in security. These two comes in security. This one, and this one comes in zips and jar files. And zip and jar file అంటే security అంటే encryption, decryption, compression, uncompression. And the zip and jar will compress the data, will store, will retrieve, and will uncompress the data. Right. So anyway, that we will see in the next example. Unlike input stream subclasses, filter input streams by default do not point any source, but they are having special ability to read data line by line or buffer by buffer. Hence, to read the data from text file. Okay, input stream okay. Hence, to read data from the text file line by line, create file input stream class object, and that is covered in the next presentation, I think. Hence, to read the data from the text file, create file input stream class object pointing to a text file. Pass that file input stream object as argument into data input stream class constructor. Create a data input stream class object. In the data input stream class, readline method is there. On data input stream class object, you call readline method. Readline method will go and ask a file input stream to read each and every character until it reaches to the new line character. The data input stream internally requires file input stream class read method only. Read. Each and every character will check if the character ASCII value is equal to the new line character. Until then, it will read all the characters. And for us, it is reading entire line, but it is not reading the line. It is asking file input stream to read character by character. But internally, it is checking whether the character is new line character reached or not. Until that, it is assuming as one line. So that button is reduced to us. Otherwise, you can also write such a logic. So, and then call readline method. Then from the data input stream, you will get line. So like that, line by line, you read till end of the file. Suppose if you want to read buffer by buffer, instead of using data input stream class, you can use buffered input stream class. Buffered input stream class can at a time each read operation can read instead of line by line on buffer by buffer. That is, there is no limit of new line character. 1024 bytes means 1024 bytes. You ask 10 KB, 10 KB data, it will read at a time. So in my view, see, how do you determine whether to go for data input stream or buffer input stream? If you are reading from a text file, data input stream is better. If you are reading from a binary file, buffer input stream is better. Not if you want to read line by line, data input stream and buffer input stream. If you want to read data from a text file or any file which contains new line character as a separator at the end of the file, then you can use data input stream on that. If you want to read a file which is not having new line as a separator, something like binary content such as image or video files, Excel, or documents, etc. In such cases, you would better use buffer input stream. So irrespective of the new line character, at a time you will read 1024 bytes till the end of the file. So that is how this presentation is completed. In the next presentation, we'll see more examples on these data input streams and buffered input streams. So until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.